Okay, let's look at some example of questions on the concept of work done. We have a body resting in the smooth contact with the horizontal plane, move 2.6 meter along the plane under the action of a force of 20 Newton. So we have this body and we have 20 Newton here that move it for a distance of 2.6 meter. So what is the force if it exerted horizontally? That will be force equals work done equals to force times the displacement. So we have 20 times 2.6. Okay, and if it's exerting at a direction that is 60 degree to the plane, then we draw like this. So that's the force here, 20 Newton, and the angle here is 60 degree. So what we need to do is that we need to resolve the force into the direction that is same as the direction of movement. Okay, so we have work done equals to F prime times distance, which is F cos theta times 2.6. So if you sub in the value, then you should be able to get the answer. Second example. So second example, we have a forklift here, lifting 16 crates. We have 16 crates, 1/6. Each of them is 256 kg, 250 kg, raised 3 meter. So you get raised 3 meter. Forklift, so you can see the fork here. So forklift. Okay, right. So raised 3 meter to be placed on a platform that is 3 meter high. Find the work done against the gravity by the forklift. So work done against the gravity. So what is meant by this against the gravity? In the equation, work done equals to F times S, right? So in this case, we're actually not told about the force that the forklift is trying to exert. So what we can do is we need to deduce from what is said in the question, work done against gravity, because we know that gravity exert a downward force. So gravity exert downward force on the crates, and therefore if we were to lift it up, or if the forklift were to lift it up, it must lift with a force that is at least equal to the gravitational force. So for example, I have something here, don't tell my son about that. So I have something here that is kind of heavy, so I want to lift this up. So my hand would at least need to balance its weight, then only it won't fall, right? So I need to balance at least its weight in the perpendicular direction upward. And if I were to lift this higher, so which means my hand would now have to at least exert a force that is equal to the weight, which is the downward force. So if that force is smaller than the gravitational force, then of course it will get pulled down, right? Because balance of the force, right? So if I exert a force that is higher than the gravitational force, then it will accelerate up. Okay, so we assume the case here is a constant speed moving up by the forklift, and therefore the force exerted must be at least equal to the total gravitational force or total weight of the crates, which is 16 times 250 times 9.81. That's the weight of 1. That's the total weight of 16. So we times it by 3. Okay, and you should be able to get the answer. Let's move on to the next question. A small block of mass 2 kg slide for 0.8 meter at constant speed down the face of a plane, inclined at 30 degrees to the horizontal. Okay, contact between the block and the plane is rough, so it's rough. Okay, give answer in terms of G. Find the work done by the weight of the block. Alright, I have drawn a diagram here indicating the inclined plane 30 degree to the horizontal, and it moves 0.8 down the lane, and the weight is 2g here. So we know that it slide down is because of the gravitational 2. Therefore, if we were to write the equation for the work done, that will be because of the gravitational force, which is in the direction of the movement, times the s. So in this case here, it will be the 2g sine 30 degree. So if you forget how to resolve this, you need to revise it a bit, and times the 0.8. So that is the f prime that I written just now, the component of the gravity in the direction of the movement. Okay, so you calculate that, you should be able to get the answer. Normal reaction between the block and the plane. So normal reaction means this. There's a normal reaction, let's say n. Okay, and we can see that the normal reaction basically is perpendicular to the direction of the 0.8 meter move. Okay, which means that like the case of the waiter earlier, this one actually will be 0 because we cannot resolve a force into a direction that is perpendicular to itself. Okay, so n will be 0. Okay, and therefore work done will be 0. Work done against friction. So work done against friction, but we are not informed about the magnitude of the friction. But we have a clue here. Let's look at these two words. Constant speed. Constant speed means that the block actually is not accelerating. It is just moving with a constant speed. That means it is having a 0 acceleration. So 0 acceleration means that the forward force and the backward force must be equal. Then only can give you a 0 resultant force. So having said that, means that the gravitational force, the component of the gravitational force, and friction, which is acting in the backward direction, will be equal. So means frictional force basically is the same as the gravitational force in the direction of the motion, which means our work done will be the same. That means it will be exactly the same that you get the answer in A1. Okay? Right, there are 2 more questions down here. That will be your assignment for the day. Okay, so write down the working clearly and then submit it in. Alright?